So the difference rule comes into play when we're subtracting two separate things, or you could say terms, whatever. So 10 minus radical x, 3 minus x squared, 1/2 minus x to the negative 1/2. So the thing about that is, it's almost like the sum, except what? It's subtraction. So let's figure out how to figure that out. Again, we're going to do a proof. I might go through this one a little bit quicker. We're going to, again, call this S, even though I know it's not sum, it's difference. Maybe we should call it D. But anyways, a new function whereby it's equal to one function minus another function. So S of x plus h is going to be f of x plus h minus g of x plus h. Almost like the last proof, but minus. So when we plug all that stuff into the derivative of s of x plus h would be this, and then s of x is just defined as the difference between these two functions. We're still going to distribute this minus into both of these, but here's the real difference. The first one is minus, the second one becomes plus. Okay, so when we regroup, it's now, when we regroup the f terms together, it's going to be f of x plus h minus f of x, and it's going to be minus g of x plus h plus g of x. Now this next step is kind of tricky. We're going to split this up into two separate functions like we did last time. So first we're going to have f of x plus h minus f of x over h. The next one, since we're pulling a negative out, that's going to leave this term negative. So this function is going to be g of x plus h minus g of x over h. But notice, this is just the derivative of f, definition, limit as h approaches 0. This is just the derivative of g. So when we split them up into two separate limits, both as h approaches 0, this is just f prime of x, this is just g prime of x, just like the last proof, except we have a minus in between. Okay, and that goes back to, oops, I'm jumped too far back. That goes back to this original minus right here, so this becomes minus g prime of x, because it's minus limit as h approaches 0. So this is just like the sum rule, except it's the difference of the derivatives. That's it. And here is your rule, written it out more formally. The derivative of the difference between two functions is f prime of x minus g prime of x. Just take the derivative of each function and then just subtract them. That's why it's called the difference rule. So I've already taught you the derivative of sine, okay, and we can use the power rule to figure this out. So we've got it into a familiar form. Again, we'll be using the constant multiple rule as well as the power rule for the second one. Okay, so now this is the rule, the difference rule, and we're going to use constant multiple, and we're also going to be using the power rule. All right, so the derivative of sine we've already shown is cosine, and the derivative of 4x cubed you should know by now. Using the power rule, we get 4 times 3x squared, which is 12x squared. Since the derivative of sine is cosine, we can just find the derivative of that, find the derivative of this, and subtract them. Final answer is cosine x minus 12x squared. In other words, the first derivative minus the second derivative. Again, here's kind of where we started and where we ended. We started with sine of x minus 4x cubed, derivative is cosine of x minus 12x squared. Let's do one more real quick. Again, I told you could have multiple terms. In this particular example, we have sum and difference, but it doesn't matter. We can find the derivative of each. So first of all, basically, we're just going to do this real quick. We're going to find the derivative of this minus the derivative of this plus the derivative of this minus the derivative of this. Okay, it's already in good form. That's what we're going to use. And like I said, this one we can actually do. You're going to get to the point where you can do it without having to show all your work. And I hate to say that sometimes, but in calculus, it gets so thorough and everything that sometimes you just don't have time to show everything. But anyway, this is going to be 5 times 4, which is 20. Subtract 1 from 5 is 4, so it's 20x to the 4th. Then we subtract the second derivative. 3 times 6 is 18. Subtract 1 from 3, 2, so minus 18x squared. Then the derivative of 9x is just 9. Remember, it's a constant multiple rule. Derivative of x is 1. 9 times 1 is 9. And the derivative of 4 is 0. This is our final derivative. So that's kind of putting everything together as far as the derivative of a polynomial goes. We use constant multiple, power rule, sum, and difference. That's it for the entire series for derivative of polynomials. That concludes the series. If you have any other questions about the derivative of polynomials, let me know.